Good afternoon, everybody, or super good early morning in Arizona. I am Mihai Dascalu, a professor at UPB, and it's my utmost pleasure and honor to introduce Danielle McNamara, director at SLERD Lab and professor of psychology at Arizona State University. Starting from a linguistic background, and that's really important because, in terms of language experiments, Danielle has a PhD in cognitive psychology at University Colorado Boulder, and she focused most of her work to better understand cognition and learning, with particular focus on both reading comprehension and writing. Danielle has been a promoter of NLP in educational processes for way before NLP was hyped. So long ago. On my side, we've been working with Danielle for more than 8 years. I went to ASU as a Fulbright scholar, and we've got more than 50 joint papers. So overall, it's been pure pleasure, and thanks a lot. Although being quite far away, one from another, from a geographical point of view, so it's a 10-hour time difference, it feels always that we're super close, and I'm more than happy that she's now virtually with us at SLERD. So, Danielle, you have the screen.
Oh, thank you. Thank you so much, Mihai. It's wonderful to be here. I'm glad I could join you for your conference. I'm sorry I wasn't able to join for more of it. I'm going to be talking about mainly technologies to enhance literacy. And really, I just want to chat with you about my perspectives from what I've called interdisciplinary behavioral science. I've had a little bit of a, a struggle with how to define myself. And coming from a cognitive perspective, you're not allowed really to call yourself behaviorist. So, but behavioral means behavior. And along the way across my career, I have taken up an interdisciplinary perspectives on the kinds of things that I'm doing. And for the most part, what I'm interested in is behavior and changing behaviors. And primarily, but not exclusively, from an educational perspective. And so this is what I've called myself, an interdisciplinary behavioral scientist. And so my goal today is to simply share that with you and to talk about how I think about things from that perspective. And I'm going to focus on literacy because a lot of my the technologies that I develop center around how to enhance literacy. So let's see. Now it's not working. There we go. So let's talk about literacy a little bit. And there are multiple aspects of literacy. You can think about science literacy, math literacy. I've tended to focus on reading and writing in those aspects of literacy. So how people use language, how well people use language according to certain societal standards, how well they can read and how well they can write. So, and helping students to improve their skills in those domains. So why do I do that? One of the reasons is because there's so many people who can't read. So approximately, there's some estimates of 750 million adults in the world can't read. Estimates around 30 million adults in the United States cannot read. 55 million adults in the EU have literacy difficulties, basically means they can't read. And at least for the United States, and I believe in the EU and the world, the estimates are worse for students who don't graduate from high school, who are second language learners. In English, that would be English language learners, Hispanic adults in the United States, and Black adults. So basically minorities, wherever you are going to have more challenges than perhaps the non-minorities. So why do I focus on reading and writing? One of the reasons is because it's so linked to learning. So if you can't read and write, it makes it very hard to learn other domains, learn basically anything. It's fundamental to be able to process language, comprehend language deeply, and to be able to write about your experiences. So sharing and expressing the knowledge that you've gained is critical to the learning process. So, and in particular, one of our challenges is increasing the number of students in STEM. You all are in STEM. Most of you are computer scientists or mathematicians or data analysts or scientists of some nature. And, but it was hard for you to get where you are. And what we need to do is to help other people to, in essence, get to where you are. To be able to understand, comprehend complex text is critically important for learning in STEM contexts. And so there's a gateway problem. We want, you know, you can focus on the STEM, but if they can't read and write, there are going to be some barriers to helping the students toward that goal. And so essentially more skilled readers, they better understand science text, they perform better in their science courses, and they perform better on state standard science tests. And that is across all domains. There's links between literacy and math, literacy and science, and literacy in multiple domains. So I've tended to focus on solutions around technology. That's my comfort zone. Not using technology, I can't turn on a TV. So, but my comfort zone is in developing technologies and putting together different parts of technologies to help students. Part of that comes from having come from a cognitive science background, and part of it stems from way back when I was an undergraduate and taking computer science classes. And so today I'm going to just briefly cover and talk about, from these multiple perspectives, 3 literacy technologies that we've developed across my career. One is Cometrics. Cometrics is a system that allows researchers to analyze language from the point of view of understanding text difficulties. So Cometrics in particular focuses on understanding aspects of language that are related or tend to be related to text difficulty. I did this, I focused on this because across my career, I worked on aspects of text related to cohesion, but there were no technologies available to actually calculate cohesion. And then recognizing that there were other aspects of language that, in essence, you had to look up in a book and then write it down and then put it all together piecemeal. And so my objective was to put that kind of information in one tool. The second is iStart is a tutoring system to help students better understand text at deeper levels. And it has multiple components, and I'll talk about that in just a minute. And then there's Writing Pal, and Writing Pal focuses on writing. And it provides students with training and practice in writing strategies and helping students to compose essays with feedback. And then I point out this book, which covers various chapters that describe technologies on literacy. So let's talk about the interdisciplinary behavioral science and that perspective and what it comes from and where I'm coming from. I started actually in linguistics. I taught English as a second language in France and the United States. And so I was, obviously, if you get a degree in linguistics, you're fascinated with language. And I then moved, in essence, I'll say, back to experimental psychology, because I started off in clinical psychology, but after linguistics, and then discovered that I had a passion for running experiments and science, and in particular, how people think. How do people process information? From there, it started to come together, and mixing together computer science, which I had some small amounts of training across my career, and learning science, which was the focus and actually emerged during my career. It started in around the 90s. And then, of course, data science and learning analytics became integral to what we are doing. And then the center of it, education. So a lot of what I do has to do with the educational experiences of students and how to improve education. And so I want to talk about learning technologies, basically from a learning science perspective, or a way that I have been thinking about learning technologies just this year. And so this is kind of brand new, but in essence, what we have when we're developing learning technologies is we have individual factors. So you are developing learning technologies for an individual. And those individuals have various aspects. They have age, grade, ethnicity. They have psychological factors such as engagement, psychosocial factors, belonging, ability, prior achievement, reading skills, and things that we can observe. So when we have learning technologies, we can observe their actions online, their time spent on assignments, videos watched. In a classroom, that's different. But for that, I'll move to contextual factors. So students are often in classrooms. We have learning context, the teacher engagement, instruction modality, the other students. I've only named a few here. And the instructional design strategies. So how many, your testing intervals, your instructional strategies, your ed tech affordances. So whether the type of learning analytics. So these contextual factors are often interact with these individual factors. I've focused on, for example, reading skills, language proficiency, some fixed factors, some observables. Others might tend to focus on other factors like psychological factors. And then in the contextual factors, there are many people developing learning technologies that focus on various factors in the context. And often we think about how the effects of contextual factors might depend on individual factors. That's the essence of developing educational technologies, is manipulating or providing the context that helps the student, the individual, to, for the best, so to speak, that optimizes training. And then on the other side, what we have is AI. So we have artificial intelligence that we are, most of us use, many of us leverage artificial intelligence. I mean, if you're even using regression, you're using artificial intelligence to some machine learning to some degree. And so what you're trying to do is predict the individual's performance on various outcomes, or you're predicting their performance in terms of their ability, their long-term ability, their psychosocial factors, and then linking those to the outcomes. So you may or may not find yourself in this outline, or you may think that it doesn't quite capture. I'd actually like feedback on it if you might, because I want to write a chapter on this. So moving on, I'm going to come back to this. So another aspect of our work is the actual stakeholders. So we have, many of us, if we're doing educational technologies, have teachers. The teachers have many barriers, and so such as they might have fear of failure. They may not want to use TED Tech because they don't know how, they don't have enough time to devote to practice or to practice even using the technologies. Maybe you're developing educational technologies that have no connection to their pedagogy. And so it's important to think about that while you're developing technologies. So there are various factors to think about when you're developing educational technologies, such that you are linking it to the needs of the person using it, the student or the teacher. So we have students, we have researchers and teachers. And there are various aspects of those stakeholders that we've had in mind when we've been developing our technologies. And so I'm going to talk about it from those perspectives as well. So going back to the three technologies I'm going to talk about very briefly, we've got Cometrics, iStart, and WritingPal. So let's start with Cometrics. This is one view of it. It's quite simple. You enter a text and then you are given these various aspects of text. I'll say that we've developed a lot of tools like this, quite a few tools that allow researchers to understand text from multiple perspectives, not only for text difficulty, but for cohesion and focusing on lexical aspects of text. Or I've worked extensively with Mihai and Stefan on Reader Bench, and that's a much more global perspective. So, but the underlying aspect of Cometrics is that it's using a theory of how people understand text to drive which features that are being provided to researchers. So let's look at those linguistic properties. So mainly in Cometrics, we provide linguistic features related to readability and the quality of text. So for example, if you have this text, I'm sure this is probably a text you read last week on neuroscience. Just kidding. And in essence, you have lexical sophistication. My guess is in this text, the lexical sophistication is pretty high, which is going to make this text quite difficult to understand unless you're highly familiar with this area. We also have syntactic simplicity. Very often, actually, in narrative texts have greater syntactic complexity than scientific texts. This text in particular probably is quite difficult in terms of syntactic complexity. But that another aspect of text is cohesion. So the degree to which the writer has linked ideas and concepts together across the text from sentence to sentence and across the entire text. And semantics, in essence, what is the quality of the text? What are they talking about? What is the topic? Is it a narrative text or is it an informational text? What is the flow of the topics across the text? So let's talk about Cometrics and meeting the needs of multiple stakeholders. From the student's point of view, what we're attempting to do is we've conducted a lot of research on how to construct text passages and assessments that consider multiple aspects of text difficulty in relation to the student. So trying to, in essence, match the reader to the right text, but looking at multiple levels of aspects of text difficulty. Another tool that we have developed is called Terra, that provides profiles of text difficulty and descriptions of how text can be more or less challenging using 5 components. And that's geared toward the teacher. And so teachers use it to gauge the difficulty of their materials or to find materials for their students that have, in essence, the right level of difficulty given their pedagogical goals. And then for researchers, of course, it provides linguistics indices on text that they use for researchers, as well as many, many corpus studies. And this ranges from researchers in the area of text difficulty, as well as clinical researchers, and in essence, a whole slew of different domains who have used Cometrics. So talking about Cometrics from the multiple interdisciplinary behavioral science is pretty easy. Of course, it is focused on linguistics and language. We use data science and learning analytics to analyze text and, in essence, discover and then provide algorithms that describe text and their components. And then it's based in cognitive science in the sense that the theories of text comprehension have driven cometrics. The linguistics are not, indices are not random. They are inspired and by theories of how people understand text, and they also confirmed theories of discourse processing. Learning science related to learning science in the sense that people learn from text. And we've done many, many studies, experimental studies that have confirmed and examined the degree to which these aspects of text are relevant to text comprehension. So finding cometrics on here, we can see that it is focusing on reading, so that how well students understand text. It also focuses on context and contextual factors in the sense of how do teachers use text and how can we help teachers use text. It's an educational technology to some extent, particularly Terra. And of course, artificial intelligence underlies our ability to provide the component scores as well as the various indices. So switching now to iStart. So iStart began with self-explanation reading training. It was an intervention that I developed in the 90s that was live. And then I modified that so that it provided adaptive instruction and training and for reading comprehension using automated methods. It provides automated instruction on self-explanation reading strategies, such as making bridging inferences and elaboration. And the backbone of iStart is that students self-explain text, and they're encouraged to use reading strategies that underlie successful comprehension, such as making bridging inferences and elaborative inferences. Natural language processing algorithms drive the feedback algorithms. The feedback algorithms are driven in essence by pedagogical theories. Then you have the tutoring system itself. And so that's a completely different aspect of it that is involved in this multidisciplinary aspect of perspective of developing educational technologies. Because there is the development of the pedagogy, how are we going to, where are we going to put various things? Human factors plays a huge role, design plays a huge role. We haven't focused a lot on design until recently because that depends on funding. But it all comes together from multiple aspects in developing iStart. So evaluations of iStart, in essence, what we want to know in iStart is the degree to which students learned comprehension strategies and how well they understand them. And that's what we've examined, and many studies have supported that iStart is effective in that way. It also improves reading comprehension ability. Students, after using iStart, they are able to understand more challenging text. Another aspect of all of our tools that we develop is they are game-based. So students practice using these strategies in the context of games, and studies we have shown indicate that students enjoy, and they're more persistent, they're more likely to be more engaged in the practice. They don't learn better because the learning is actually driven by the underlying pedagogy that for iStart. So if we compare non-game to game, it's really the engagement and the enjoyment that is affected by the games. So meeting the needs of multiple stakeholders. So what we have is for the student, of course, it's pretty clear. It provides adaptive tutoring to improve comprehension of challenging texts. And so we've focused on how to maximize, optimize learning and their improvement, as well as their enjoyment and engagement. For the teacher, we've also focused on the teacher aspect of it. So we have spent a huge amount of time developing teacher interfaces, which is a lot harder than it may seem. So how to visualize, how much information do you give them? The tutoring interface for iStart allows them to choose text. It allows them to enter text. It allows them to choose modules, which games they should use, and then if they view performance at multiple levels. So how much of that you give to the teacher and how much of it and how to visualize that is a huge aspect of our development process. And then we also have an experimenter interface. So as we have moved along, we recognized that, in fact, we needed to be able to run experiments on the fly. And if it was hard coded, then it was going to take more time. So we have a complex but easy to use experimenter interface that allows us to set up various modules and various algorithms before an experiment and set up classrooms for various experiments. I'll say that I'm always happy to allow to collaborate, and people are welcome to use iStart in their experiments if you would like to better understand comprehension and how and various aspects of tutoring. So from iStart's perspective, I won't delve much into this. You might have the picture already on how these various aspects and domains and disciplines play a role. And there even more disciplines are needed, that it takes an interdisciplinary, multidisciplinary group of individuals to develop these kinds of tutoring technologies. And then from this perspective, perhaps you can see iStart here that it's focused on individual factors in improving students' comprehension. It depends on their prior achievement. So their reading skills in the student model depends on how well what they come in with and what kinds of texts that they can already read. The contextual factors are huge because iStart works much better in a context where we develop a community of learners, a community of readers, where the teacher understands and is also covering these concepts along with iStart. So teacher engagement in this process is very important. And then obviously it depends on artificial intelligence, because NLP is the driver of underlying driver of iStart, in the sense that the student is typing in their responses, or we're building one that they can verbalize it, but they are entering their responses, and the algorithms are built to detect the quality of the text of their responses and what they're doing and what needs to be done next. Okay, so Writing Pal. I hope I don't go too long. Writing Pal is a tutoring system that is focused on writing strategy. It is from the perspective of writing theories, on that it is not a linear process, but there is, in essence, processes related to drafting, planning, drafting, and revising. And so we have strategy instruction on pre-writing, drafting, and introduction, body, and conclusion. And our main focus is on strategies. Across all of our tutoring systems, we're attempting to teach students strategies, shortcuts, so that they can catch up. The less skilled writers and readers can catch up to the more skilled. And that's very key to the kinds of tutoring systems that we are building. And so they are taught strategies within the context of these modules, where They practice the strategies, they learn about the strategies, and they practice the strategies in the context of games. And then they also write whole essays. So it goes from part to whole training. And the teacher is, the students are given feedback that links back to the strategies that they've already learned. It has student, teacher, and experimenter interfaces where the student is, and in essence, has this system that is modified based on what the teacher or experimenter wants to cover. And the teacher also has an ability to modify the modules, use whatever modules they want. And then also they are able to observe the student's performance. As I said, Writing Pal focuses on strategies to improve writing. So there's a writing interface where they are enter their essay, and then they can also go back and see their previous essays, and they are given feedback that points to various aspects that they can improve. So Writing Pal, I'll just say it works. It increases performance on time prompt-based essays. It increases knowledge of writing strategies, more positive attitudes toward writing, which is very important. And the games, again, they enhance enjoyment. And we, just like I start, students report positive attitudes toward the Writing Pal. So again, meeting the needs of multiple stakeholders. I've already said most of this. We focus on the student and how the student uses the system and whether it works. We have a teacher interface as well as the experimenter interface that allows the experimenter to control various parameters and aspects of the learning process. And then this is pretty clear. The various domains that have come into Writing Pal and how it is clearly an interdisciplinary, multidisciplinary process in its development. And people come at it from different angles and different foci and what they are most interested in. And then again, I think you can see that it's a tutoring system that focuses on the individual and how well they write. How well they write when they come in is important. And the contextual factors, it's important that this is embedded in a class and that we support the teacher. It's an educational technology that is driven by artificial intelligence in the sense that the artificial intelligence is used to create the automated writing evaluations. So one aspect of what I'm talking about is that this is not easy. Interdisciplinary research and development is not easy. If I were in a room, I'd ask you to raise your hands, and maybe you can kind of verbally or internally raise your hand or not on how easy you think it is. I think it's very hard. We've made lots of progress in the last 20 years in interdisciplinary research. There's more funding for it. There's a greater push for it. There's more even requirements from funding agencies that projects be interdisciplinary, as it is recognized that single disciplinary projects often don't make the mark that interdisciplinary research does. But it's hard to get people together. It's hard to get people on the same page. It's hard to get people to speak the same language. People are coming at it from different goals, different angles. And so getting these kinks, getting these wheels to work together is sometimes challenging, but it's necessary. But the last two decades, I think, have seen substantial advances. Educational technologies have a lot of potential. So they reveal learning. You have automated and stealth assessment now. We have AI and machine learning, and we're making huge progress on developing methods to reveal the learning process and augment human capacity. So We can support teachers and parents, inform policymakers. We can provide automated tutoring, stealth assessment, and we're able to orchestrate learning interactions more and more between the students, parents, and using artificial intelligence, pedagogical agents. So we've made a lot of progress and it has strong potential. What we're not seeing very much of is making a dent on literacy gaps. So we are kind of grasping at the wind and pushing against essentially what's happening in society. We have hope in the sense that we need to increase, to make a dent on those literacy gaps in order to improve aspects of reading and writing and science and math. And hopefully if we can make a dent, we have to make a dent since literacy gaps are linked to employment, whether people have jobs, so joblessness, unemployment rates, the tendency or probability that someone will go on to higher education. Will they go on to get a college degree? Will they finish high school? Society and the quality of society is to a large degree relies on the literacy rates of their population. And then health. If an individual can't read a label, if they don't know enough about health, if they can't get medical attention, then they are very much more likely to have health problems, and that has in turn a cost to society. So this is one of the reasons why I tend to focus on literacy gaps, is because it's just so fundamentally important to society. So that's about it. I'm looking forward to your questions and having a conversation about the things I've talked to. There's lots of details I've left out, so I'm happy to talk about those. I do want to thank my research faculty and postdoctoral scholars that are currently in the lab. I could have thanked also the hundreds of others that have contributed to the research I've briefly talked about today. And then also my colleagues who are across many of our projects. And then of course, Mihai and all of his students, including Dory, who are fundamental to much of the research that I'm doing now. I almost call Mihai my right hand on the other side of the world. So that end with a plug. I just started a journal, Technology, Mind, and Behavior. Please have a look at the papers. I think they're very interesting and quite interdisciplinary. And then thank you. I'll end there. And then of course, all my plugs for books. Buy my books. I don't get any money from it. You can buy them though.
Thanks a lot, Danielle. Awesome talk.
You're welcome. It was my pleasure.
Awesome. So time for questions, please. Okay, Carlo.
Thanks. Thanks for your very enlightening talk. It was very interesting to have this overview on recent progresses. And I have a question for you about, so you underline the contribution of artificial intelligence to predict, of course, and to support learning, and also to close the gaps. But as you know, artificial intelligence can also modify our brain frame.
What? I'm sorry?
As you know, in artificial intelligence and any, let's say, intelligence support may modify our brain frame and skills. Just to make an example, think to our spatial orientation capability, how they have changed due to the use of Google Maps. Okay, just to make an example. And of course, also tend to generate standards And for example, I give you in writing, just to make another example, it's not very rare now to meet a reviewer that cannot accept any not standard approach to a scientific paper. Okay. So they tend to react more or less as a robot when they are reviewing a paper. Okay. So I just asking your opinion about the interplay between human artificial intelligence in your domain. In some sense, your future vision about linguistic and how will change the related skills, the human skill in the future.
So in essence, what I'm understanding is what's the distance between this algorithm, the artificial intelligence, and then the actual outcome that you're seeking. So if I'm using artificial intelligence or intelligent tutoring, what's the distance between that and then actually having an effect on an individual? Am I understanding or translating the question right? Mihai, do you want to, you look like we want to come in.
Something, and Carlot, correct me. I understood also the backwards loop. So AI is changing our behaviors because for example, while using Google Maps, it makes us oriented easily with Google Maps, but we lose complete orientation if the instrument is not available.
Yes, indeed.
Sometimes the same thing for writing. We've got cool instruments.
You know, I cut half of my talk, and I'm not sure if it's relevant, but it has to do with ed tech companies and the dominance of those companies. And I'm not sure if that is kind of the grounding of your question. Mihai, do you think that is what we're focusing on?
No, I mean, I can rephrase it if you like.
Please.
Okay, so okay, I'll say the Mihai. Of course, artificial intelligence could be very useful to close gap, to training, to help in training, etc. But often when we give some, let's say, scaffolding to people, we are also changing their own brain frame. Okay, that means that in some sense we are acquiring some skills and we are losing other skills. Okay, so and this is because, of course, we provide some scaffold that then make not any longer useful a certain number of skills. Okay, this happens to orient in oneself, and this happens also in writing paper or whatever. I mean, so my opinion, my question was, in your opinion, how will develop the interplay between humans and artificial intelligence in the future, and how the competencies in linguistic will be changed by this interplay? Is now more clear?
Right. So that's a really kind of deep question about the use of technologies in society and the degree to which those societies are in good or bad. Do they have good effects or bad effects? Will we lose skills as a function of using various technologies? Relative to my case, you might say, well, do people really need to learn how to read and write? Is social media and watching videos or getting information off of YouTube going to take over how we process information or change how we process information? So I think that there are some fundamental aspects of how we process information and how we can learn information that are independent of the technologies that we use. And those are the ones that I tend to focus on. Writing is more than just writing an essay. Writing is the ability to take something that we know and communicate it to others. And that ability is fundamental to survival in society. So our use of strategies and how to construct information, how to organize information, how to make sure that we understand the information that we're attempting to convey is fundamental to our ability to survive, regardless of what kinds of technologies we have available in our society, or what kinds of technologies that come around, or what kinds of modalities that we're using. Even in the case of creating an images, we have to pick those images that will convey those ideas most successfully. That is part of writing. Putting images together is writing. To a large extent, you are composing. And reading, I will say that people do not learn from videos. People do not learn very well from having information given to them. No matter how much you scaffold that information, you have to produce information in order to learn information. You have to generate information, you have to say it, you have to write it, you have to generate it in order to learn it, because it's the only way to connect information to what you already know. And so a lot of what I'm doing is connected to, as I said, cognitive science and learning sciences on fundamental aspects of how we learn information. It's why I focus on these kinds of tutoring technologies. Another aspect of what you're asking is that there is a large distance between the language that they're using and the actual tutoring technology. That's the interdisciplinary part. How to optimize the pedagogy and how to create a tutoring technology. I've modified these tutoring technologies at least 20 times across my career because of changes in operating systems, in programs, and expectations of students. So those expectations also drive how tutoring technologies work and how you can use the technologies. Let me go on to another question, because I'm still not, we can come back if I didn't answer it quite.
That's okay, thanks.
Trian, I see you raise your hand.
Thank you, Daniel, for the great talk. It's a pity that we cannot meet you in Bucharest. Probably, if the conference would have been in Bucharest, it would have been more difficult for you to come. So it's great
Someday.
It's online.
Someday.
Like my questions are more from the ML direction. The first one is like NLP has been transformed by deep learning and right now by transformer models. Can they be applied for reading comprehension? My question is more related to the fact that they are not explainable, and I guess that you need explainability for your models. The second question, I think it's a little bit related to Carlo, and it's more like ML models kind of give you an average, or it averages over several data points, and in many situations you kind of get this very average answer, like everybody will kind of write the same. I think this is what Carlo means. You get into some standards which are learned by these models, and then is there, do you see like a problem that people will lose like complexity of writing, and because all these models will say write like this, like this, like this, like this, and kind of go in losing some of the variability and fantasy of language. And like the third one, and this is like interesting for me as a NLP researcher, I think that there are few open data sets related to this domain. Do you think it would be more useful? Like computer vision has risen a lot because their data sets have become open in the last 20 years. Right now, NLP data sets also are kind of becoming public. Do you see any future directions where these data sets in tutoring systems for NLP will become open, or are there problems with this? Like, I don't know,
Okay.
Privacy problems. Thank you.
Okay, that was 5 questions. So so one aspect of what you're asking is about deep learning. Another, the fundamental question is about individual differences, and the other is about the growth and availability of data sets. Okay, I'll start with the last one. It's the easiest. In my career, data sets has been the biggest barrier to developing our systems, collecting data sets, scoring data sets, and knowing that many companies, several companies, okay, two, have all the data and all the power, and that's frustrating when they won't share and haven't shared across my career. And now there's a big push to share and put these data sets online. I think it's huge in terms of pushing the field. There's been an enormous increase in the use of natural language processing in the last 10 years, just absolutely huge. For not just natural language processing, but more, I would say, deeper language processing in the sense of using multiple aspects of language. And this is related to your second question, which is about how you can cover variability of individual differences. I'm an individual difference researcher. Everything I do covers individual differences, which means that you have to have an individual difference measure. So for all of my research, we're also collecting reading skills, writing skills, and knowledge, sometimes motivation, but only to show that it doesn't have an effect. And so the point of intelligent tutoring systems is to modify the algorithm as a function of the individual. So it's always geared toward the individual if it's actually an intelligent system. And so, for example, I'll talk about writing and the importance there. You're absolutely right in that the writing algorithms, what we've discovered, one of our studies, maybe several, have shown that the better writers use different strategies. So, for example, a good essay may use cohesion as a means of better conveying the information. Another may use narrative. Another may focus more on information. And we've used clustering algorithms to identify what strategy they're using. Now, this also relates to the average in the sense that this is dynamic. So whereas a writer may use that strategy in one situation where they know less about the domain, they may use a different strategy for a question where they have more knowledge or they have more comfort in expressing their ideas. Better writers are more flexible, and that's important. And so across everything, we're attempting to identify where the individual is and how do you modify the learning environment as well as the algorithm and your pedagogy to fit the individual. And so then one of the things you asked, the first thing you asked was about deep learning algorithms. So we just had a good old LSA and LDA, and that was our superpower. It didn't work very well. We didn't use it very much, actually. We said we did because it sells, but it's not that good. And so, but my focus in my career has been on linguistics, and the LSA is a means of capturing semantics. So for example, if you have cohesion, you can have cohesion at the word level, and you can also have cohesion at more of a flow level using LSA, essentially expanding the model semantically. And so my assumption about linguistics is actually fundamental. It's not loose. And my fundamental assumption is that we can understand how people are thinking by analyzing the language that they're using. And in essence, because the language they're using is linked to their processing, brain activity, if you will. And so when someone writes an essay, we can do linguistic analyses of that essay and be able to predict their reading skill, their knowledge, domain knowledge, their word knowledge, their language sophistication, various aspects of their ability that can be used for self-assessment. In addition, of course, to writing ability, because of course we have writing analyses, but the words they're using are fundamentally linked. Now the question is BERT, good old BERT. It's a good question. It's one we're asking in all of our studies. Linguistics or BERT? Linguistics or BERT? And really fundamentally, the question is the degree to which, BERT's not going to work. Word2Vec might, in context where you don't have very much data. And linguistics work also because they're more explainable. But I want to point out that explainability is not necessarily linked to the algorithm. Explainability is linked to what you are predicting. So it's not explainable if I just have a holistic score. If I just have a holistic score from 1 to 6, then, well, okay, I'm predicting 1 to 6. So what? What do you do? What's the pedagogy behind it? But if I have a rubric and I'm predicting, for example, I'll stick with writing, the voice or the cohesion, or the quality of the introduction, or the quality of the conclusion, or the rhetorical strategies, then the algorithm, no matter what you're using, linguistics, and probably the best is linguistics and BERT, or linguistics and Word2Vec, it's what you're predicting and the degree to which you have a benchmark that is reliable, and then you have an algorithm that works, which is hard. So we're trying to find algorithms that work. That's always our goal. Now, but I will also say that we also have unsupervised models. We develop unsupervised BERT models, unsupervised linguistic models. Tendency is, then you can extract various features. I would not say that BERT is not explainable if you extract the important words from it. So I think that's an exaggeration. I think that saying that deep learning is not explainable depends on how you're using it. You can use it in deep learning in an explainable fashion, and you can extract aspects of those deep learning models that add to the explainability and help pedagogy. Explainability is linked to how you use it pedagogically and how you link to it. Sometimes for me, and this is something I wanted to say, and that is that the distance between an algorithm and pedagogy is huge. That little tiny outcome may be linked to a feedback module that has 40 if-then, so to speak, and parameters. So that's why it's multidisciplinary, because it's not just an algorithm. And whether it's a deep learning algorithm or a linguistic algorithm doesn't really matter that much.
Okay, thank you very much. Very, very, very nice response. I've learned a lot. Thank you.
Any other questions? We're a little bit over time, but since it's the last presentation for today, we can stay if you've got additional questions. On my side, I may have some hints, but I would like you to tell everyone what you see the biggest challenges in the upcoming years. For example, if you take a closer time span and on the longer time frame?
I think the biggest challenge is the collaboration between the various stakeholders. So one aspect of what we're faced with are, I said that educational technologies we're improving, but what we're also faced with is educational technology businesses that are taking over the world. And they have all the data and the researchers don't. Researchers also have to follow ethics. They don't. We need more collaborations with ed tech businesses. And so managing, increasing, enhancing those collaborations, not only between the stakeholders, between the teachers, students, and researchers, but also with the ed tech companies, I think is one large challenge in the next 5 to 10 years, which we may, or, you know, in essence, in some ways it doesn't matter because all of your students go to the businesses anyway, because they pay so much. And so maybe that challenge is moot.
Yep, indeed.
What do you think is the biggest challenge?
Ooh, that's tough. I like your answer, so yeah, I can copy it. Yeah.
And challenges are individual too. So one thing you can say is, what are you going to be doing in 5 years? And my answer is always the same. I think Mihai may know what the answer is.
If you start with it, I may have a hint, but it's
What's
not that. But if you start a little bit and give me a little bit more context.
Well, my answer is always, if I could tell you what I'm going to be doing in 5 years, then I'm not being very creative.
Okay. Well, yep, makes perfect sense. Again, it's been a great session, so thank you very much.